Let's say you're given the first term of a geometric series and you're given the common ratio by which you would multiply the first term by to get the second term and the second term to get the third term and so on. How would we write this geometric series? Well, we learned before that any geometric series we should be able to write it as the summation from n is equal to 0 to infinity of a1 times r to the n. And so for our series, we would write this as summation from 0 to infinity. A1 is 2, and our r is negative 1/3 to the n power. Let's check and see if that works. If I plug in 0 for n, 1/3, negative 1/3 to the 0 is 1 times 2, so our first term is 2. If the ratio that you are multiplying by, if the absolute value of that is less than 1, then we can say that the sum is going to converge to a1 over 1 minus r. So what if we said that the first term a1 was 1 and the r that you're multiplying by is x? How would that change this? Well, it would still be the summation from n equals 0 to infinity. Instead of writing a1, we will simply write 1, and then r is x, so it's going to be x to the n. And let's just see if we can write out a few terms here. When n is 0, you have x to the 0 is 1, and then when n is 1, you have x to the first, and then x squared, x cubed, x to the fourth, so on and so forth. And the sum of all of these terms is going to be a1, which is 1, over 1 minus r, and our r is x. So what we're going to learn in this video is how to recognize another series that may look similar to this and try to manipulate that other series to get it into this form so that we can use this idea of it converging to this point, and then we'll be able to rewrite the power series in this form. So let's say you're trying to find a power series representation for f of x is equal to 1 over 1 minus x squared. Well, we just established that the summation from n equals 0 to infinity of x to the n, if the x, which is your r, is between negative 1 and 1, that's going to converge to 1 over 1 minus x. Now we recognize that 1 over 1 minus x squared is similar to 1 over 1 minus x. And if we wrote out the first few terms here, we would have 1 plus 1 over 1 plus x squared plus x cubed plus ... So we can see here that all we need to really do is replace this x with x squared. So this is a substitution, and we're going to substitute x squared into all of these x's here for the geometric series, and we will write out the series this way. So 1 over 1 minus x squared is simply going to be 1 plus x squared plus x to the fourth plus x to the sixth plus ... And similar to what we did in the previous videos, we're going to replace the x in the general term with x squared as well. So that's going to be x squared to the n, which is going to give us a general term of x to the 2n, n equals 0 to infinity. And so this is our general term for this power series representation. And normally this will converge as long as the x is between 1 and negative 1. And that is part of the properties of the geometric series. The r, the absolute value of r, must be less than 1, which means r must be between negative 1 and 1. And so if we're just replacing x with x squared, then that means that x squared must be between 1 and negative 1, which means still x must be between 1 and negative 1. Okay, this one is a little bit more complicated than the last one, and the third example will be more complicated than both of them. So we want to do one easy one medium one, and one hard one on this video. So we recognize that 1 over 4 plus x, so let's write that out. 1 over 4 plus x kind of resembles 1 over 1 minus x. So the key for these problems, for all these problems, is we've got to find a clever algebraic way to get this into this form right here, where the top term is 1 or some constant over 1. And this is the key. This has to be 1 minus something. And it's centered at x equals 0, which in this problem won't matter, but in the next problem it will. So let's take our series, or our function 1 over 4 plus x, and our first goal is to get this term on the denominator to be 1. So perhaps we should divide everything by 4. And that's going to make 1/4 over 4 over 4 is 1 plus x over 4. Starting to look like 1 over 1 minus x. Only problem is this is a plus down here. We need a minus. That's not a problem, because now we can write this as a double negative. We know that a minus is the same as a plus, and so now we have it looking like in this form. So now we can identify that our a1 is 1 over 4, that's our top number, and our r is simply what is coming after the 1 minus, so that's negative x over 4. So now we want to take our normal way we would write our geometric series, which is x to the n, and we want to replace, or tell you what, why don't we write it this way as well, a1 times r to the n, from n equals 0 to n equals infinity. And we want to take our a1 and replace it with 1/4. So it's going to be the summation from n equals 0 to infinity of 1/4. Our r is negative x over 4 to the n power. And now we can actually rewrite this a little bit to make it look a little bit nicer. We can write this as negative 1 to the n times x to the n. Make sure that makes sense to you. All I did was break up the negative x as negative 1 times x to the n power. And then I raised negative 1 to the n and x to the n. And then I've got 4 to the n on the bottom times this 4 here. So that's going to be 4 to the first times 4 to the n. We have like bases, so we can add those two together. So that's going to give us 4 to the n plus 1. And that is our series representation for this 1 over 4 plus x. Now it wants us to write out the first 4 non-zero terms. So we will plug in n equals 0. When n equals 0, we have negative 1 to the 0, which is 1. X to the 0 is 1. And 4 to the 0 plus 1 is 4, so we already knew our first term was 1/4. And then when n is 1, we have x to the first over 4 squared. And there's going to be a negative because negative 1 to the first is negative, so that's going to be negative x over 4 squared, which is 16. And then the next one is going to be a positive. X is 2, so that's going to be negative 1 squared is positive, so x squared. And n is 2, so that's going to be 4 cubed. And then the next one is going to be negative x cubed over 4 to the 4th. And you can get this to be 16, and this is going to be 64. That's going to be 256. It also asks us in this problem for what values of x does the series converge. And so we know that normally it converges when x is between negative 1 and 1. But once again, we need to replace our x with negative x over 4 because that is the new r. And so maybe we should write this as r being from -1 to 1, but I think you get the point. So now we're going to replace our r with -x/4. And we're going to multiply everything by 4. And so that's going to give us -4 is less than -x is less than 4. We're going to multiply everything by -1, which is going to change the signs. Anytime you multiply any part of an inequality by a negative, it's going to change the sign. So that's going to be 4 is going to be greater than x is going to be greater than -4. So essentially, it's going to converge for all values from -4 to 4. Okay, this example is the most challenging out of all three because the function that we are trying to approximate by recognizing that it looks kind of like a geometric series looks nothing really like a geometric series. So we need to manipulate this using clever algebra so that we can get it into this form. So basically the big idea here is we need to take 15 over 2x minus 1 and we need to manipulate it into something that looks like this. 1 over 1 minus x. Now, here is the key, and if you miss this, the entire problem is not going to work. Nothing in the problem is going to work out for you. You got to recognize that this is the first one that we've done that is not centered at 0. It's centered at x equals 2. So that means that the term or the part that has the x needs to be x minus 2 for your answer. So we need to manipulate this. So the first thing that we're going to do is we are going to recognize that the bottom is opposite of what it should be. It should be 1 minus something. Instead, it's that something minus 1. So we are going to multiply the top and bottom by a -1. So that's going to be a -15. And on the bottom, if we multiply both of those by -1, it's going to be -2x plus 1. So that's going to now turn it into 1 minus 2x. That's not bad. It's starting to look something like this. Now, the only problem is, once again, we have this x term here, and we need to make it an x minus 2. This is where it gets a little tricky, and you're going to just have to use some creative imagination whenever you work these problems on your own. But let's just see if we could rewrite this into something that has an x minus 2 on the bottom, but is still equal to 1 minus 2x. Well, with a little bit of clever algebra, you will see that it ends up being this. You're saying, Mr. Parr, how in the world did you come up with that? Well, you're going to just have to kind of think it through and see if you can make sure that this thing that you wrote is still equal to this. Let's check it and make sure. All right, we have -3. We're going to distribute this -2 into both terms. So that's going to be -2x. And a -2 times a -2 is a +4. We have like terms here and here. So 4 minus 3 is indeed 1 minus 2x. So this is equal to this. It's just written a different way because we need it to be centered at x equals 2. So let's continue. We also need our constant term on the bottom to be equal to 1 and not -3. So we are going to divide everything by -3. So we're going to divide our top by -3. We're going to divide this constant by -3. And then we're going to divide this by -3 as well. And so this is going to give us 5. And -3 over -3 is 1. That's what we wanted. -2 over -3 is a +2/3. X minus 2. Starting to look like what we want. We've got a constant on the top. We've got a 1 here. And we've got our x minus 2, which is our center. Now we need to manipulate this plus to get it to be a minus. Well, we've seen that before in the first example, and that's going to just be 5 over 1 minus a -2 over 3 x minus 2. So our A1 is 5 and our R is negative 2/3 x minus 2. Keep in mind a geometric series can be written as the summation from n equals 0 to infinity, A1 times R to the n. So our A1 is 5, so we'll write this as the summation from n equals 0 to infinity. And we'll put a 5 there, and our R is the whole term here that's in that place. So negative 2/3 x minus 2 to the n. So that is our general term that they're asking for. Second thing they want is the first 4 non-zero terms. So all we need to do is plug in 0, 1, 2, and 3 into our general term to get the specific terms. So when n is 0, we already know the first term is 5, excuse me. So our first term is 5. When n is 1, we have negative 2/3 to the first, which is still negative 2/3, times the 5 out front, which is going to be negative 10/3. And then we need to take the x minus 2 and raise it to the first power. So that's x minus 2 to the first power. And then we need to take, plug in 2 for n, which is going to make us square negative 2/3. So we square that, that's going to be positive 4/9 times 5, which is 20 over 9, and x minus 2 squared. And then the third, when x is 3, we will have negative 2 to the third, which is negative 8, and 3 to the third, which is 27. So maybe over here we'll do that. Over here we'll do negative 8 over 27. But we can't forget there's a 5 in front right there. So that's going to be a negative 40 over 27 x minus 2 cubed. And then the last thing they want us to do is figure out what values of x does this series converge to. So we're going to need a little bit more space here. So let me erase some of this. And we said last time that a geometric series, will converge as long as the R is between negative 1 and 1. So let's write that out. Negative 1 must be less than or equal to the R. Our R is all of that. So negative 2/3 x minus 2 and less than 1. So we are going to multiply by the reciprocal of negative 2/3, which is negative 3/2. And so let's go ahead and multiply everything by negative 3/2. And when we do that, we have to remember that anytime you multiply an inequality by a negative number, it's going to flip the signs. So a negative times a negative is a positive 3/2. This sign is going to change to greater than. Negative 3/2 times its reciprocal is 1, which is the whole purpose of why you multiply by a reciprocal. So that's going to be x minus 2. And then this sign is also going to flip, and it's going to be negative 3/2. Now we're going to add 2 to all the sides. And so we have 2 plus 3/2. So that's 4/2 plus 3/2 is 7/2. That's x. And if we get a common denominator here, we have negative 3/2 plus 4/2, which is going to be 1/2. So basically, any x between 1/2 and 7/2 is going to cause this power series to converge.